Good morning, this is Ms. Billerbeck, and we're going to talk about translations, rotations, and combining transformations. A translation, in a translation, the original object and the image are congruent. Every point on the object moves through the same distance in the same direction. The orientation of the object is the same. So let's take a look at what that looks like. All right, so if we have triangle ABC here, the ABC is the object, A prime, B prime, C prime is the image. So if we put this on top of each other, it's a congruent shape. Okay, it has congruent sides and congruent angles. But when we translate, we can move it sideways on the x-axis, or we can move it on the y-axis, or we can move it both ways. Okay, that's a translation. So we do a X and then a Y. So it's basically a slide is a translation. Okay, the object is the same orientation, congruent, etc. All right. So let's do an example. So if I have triangle ABCD mapped onto A prime, B prime, C prime, D prime by translation of 5 units in the X direction and 2 units in the Y direction, what are the new coordinates of A prime, B prime, C prime, and D prime? So let's take a look at that. So if we're going to move 5 units in the X direction and -2 units in the Y direction. So we're going to count 1, 2, 3, 4, 5, 1, 2. So we have D prime right here. A prime is going to be 1, 2, 3, 4, 5, 1, 2. So we get A prime right here. B prime, 1, 2, 3, 4, 5, 1, 2. So B prime would be right there, and C prime, 1, 2, 3, 4, 5, 1, 2. So we have C prime here. So we have the exact same figure. It's just moved over in a slide. So we slid the object over. So let's look at the new coordinates. So the new coordinates for D is 1, 2, 3. So it's 3 on the X and 0 on the Y. For C, it's 3, -1. And for A prime, it is 1, 1. And B prime, we have 1, 0. Okay, so if we look at the original coordinates, okay, so for B versus B prime, well, let's start with A. A versus A prime. So we have -4, 3, and it becomes 1, 1. Well, in order to do that, I had to add 5 to the -4, and I had to subtract 2 from the other coordinate, which is exactly what it's saying that we're doing. So if I was to make a rule, I would have said, to get to A prime, I would say -4 plus 5 and 3 plus a -2, which gives me 1, 1. Okay, for A prime. Okay, I could have done that for each one of these. If I add 5 to -4, that becomes 1. If I add -2 to +2, that's 0. If I add 5 to -2, that's 3. If I subtract 2 from 2, that's 0. And the same with C. Add 5 to -2, 3. Subtract 2 from that, I get -1. So we can have a rule that the coordinates of the image of point AB, when translated h units in the x direction and k units in the y direction, is given by the a plus h, comma, b plus k. So that's how we would write a rule for that. So if we have a translation and maps to the point 2, 4 onto the point 5, negative 2, and point negative 4, 9 onto the point P. Okay, so we have a translation T. So that's our translation T. It's mapping the point 2, 4 onto that point. So that's telling us what the rule of translation is. So we need to see how far is 2, 4 translating to 0.52. Okay, so we have 2 plus h equals 5. So if we subtract 2 from both sides, we get h equals 3. If we take 4, and that's translating k equals negative 2, and we subtract 4 from both sides, well, k equals negative 6. So our translation then is going to be, translation will be x plus 3, y minus 6. So if we want to find the coordinates of P and we're given 4, so we add P prime is going to be negative 4 plus 3 and 9 minus 6. So our new P prime is going to be negative 1, 3. So if we want to do what is the image of Q at 3, negative 1 under translation twice T, well, that's just Q prime would then be 3 plus 3 and negative 1 minus 6. So Q prime then is 6, negative 7. But Q double prime, because it said twice, is going to be 6 plus 3, negative 7 minus 6. So Q double prime is going to wind up being 9, negative 13. So that's how we do it using our math. So in our next part is about rotations. So in a rotation, the original object and the image are congruent. Any point A on the object is moved through a fixed angle about the center of rotation to its image A prime. The point A and its image A prime are equidistant from the center of rotation, and the orientation of the object and the image are the same. All right, let's take a look at what that looks like. So down here we have a rotation. So this, we have to state the origin. So where is the center of rotation? So if that's going to be this point. Now here's our angle of rotation. Currently we have this angle. If we had a 0 angle, it would be on 2 congruent objects lying upon themselves. Okay, but as we increase the angle of rotation, it just rotates right around that object until it returns at 360 degrees. Okay, so that was a counterclockwise rotation. So that's 360 degrees is all the way around. There, it's a little sensitive, there we go. So that's 360. And then if I go clockwise, that's the rotation of the object. Okay? So that is what a rotation looks like. So we have to state, what are we rotating around? So this is our axis, our point of rotation, the center of rotation right here. Okay, so we have to state what that is. All right. So if we have example one, so we want to rotate about the origin A, comma B. So if I have a 60-degree counterclockwise orientation, I am going to bring out my fancy little protractor here to show you that that's not going to be very easy. So we want to set this up to 60 degrees right here. Okay, this is a very special protractor where it has measurements here, so I can easily move something like this 60 degrees. So if I'm going counterclockwise and this is clockwise, I'm going to rotate the figure this way. So if I set this up with, it has a little center of rotation right here, okay, and I set that right on the origin. Okay, so I line that up, that's my target. I make sure the 60 degrees doesn't move. And I line up my first point here, and that's right at 1 here, so it's going to move 1 here. Then I grab my little center of rotation and I do B next, making sure it's still at 60 degrees angle. So that's about 5.54, so I'm going to go to 5.4 right here for B. Then I grab this, rotate it up some more, and I'm about at 5.9 right here with a 60-degree rotation, so 5.9 is right about here. Okay, so I want to make sure I have a straight edge to do this, so you can grab anything you need for a straight edge. Here's mine. Okay. So then we take our straight prime. This is A prime. We have C prime right here, and B prime is right here. So that's just a 60-degree rotation. Okay, so when it's not at a factor of 90 degrees, it's a little rough. So you need to use a protractor to do it. Okay, but there's other ways to do it. If it's rotated about the origin and it's a 90-degree clockwise, then we can do a few other things. So we can use this as my radius right here, because this is a 90-degree angle here. So if I have a point here, then my new point's right there, because I'm just going to rotate this around. Okay, if this point here is 1, 2, 3, 4, 5, 1, 2, then I can count 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 1, 2, and have my B double prime right here. That's A double prime. So C is 1, 2, 3, 1, 2, 3, 4, 5. So 1, 2, 3, 1, 2, 3, 4, 5. So then we have C double prime. So we can draw our new triangle right here. So this is a 90-degree triangle. Rotated clockwise, not counterclockwise, but clockwise about the origin. So that's 90 degrees clockwise. All right, so if we do 180 degrees, well, that just means we're going all the way around here, and it doesn't matter if it's clockwise or counterclockwise because it's still going to be on this axis right here. So if this is 1 here, then we place 1 there. Okay, if this is 1, 2, 3, 4, 5, 1, 2, then we count 1, 2, 3, 4, 5, 1, 2. And we have B triple prime. And this one's A triple prime. Okay, and then for C, we have 1, 2, 3, and then 1, 2, 3, 4, 5. So we count 1, 2, 3, 1, 2, 3, 4, 5. So that's C triple prime. Okay, let me move that over here. So that gives us 180 degrees, and it does not matter if it's clockwise or counterclockwise. You're going to get there whether you go this way or this way. All right, so the last one is 270 clockwise. Well, that's actually the same thing as 90 counterclockwise. So 270, we start here and we go all the way around to this axis. Okay, so at this point, I'm going to erase my 60-degree angle because I'm going to need it for the 270. Okay, so if this is going all the way around, then my new point's going to be here. Okay, so that would be a quadruple prime. Okay, and then if this is 5, 2, okay, we're going to have 1, 2, 3, 4, 5, and 1, 2. So be quadruple prime. And then this is, we have 3, 5, so 1, 3, 1, 2, 3, 4, 5. So we have C quadruple prime. And then we can make a picture of that. Okay, so the interesting things we're going to find really quickly, and to save time, I'm only going to do a few of these. Okay, so if we look at the coordinates for 90 degrees, okay, so we see that our new coordinate is at -3, -5. And B prime, the new coordinates at -5, -2. Okay, so we can see that these are swapping, and then the x becomes negative. Okay, so we have a swap, and the x becomes negative. So when we move AB around, our rule is going to be B minus A. So that'll be our rule for a clockwise rotation. We swap A and B, and it becomes B minus A. When we look at C, C becomes -5, +3, and B is -2, +5. So let's look at these two coordinates. So we have -5, 3. Okay, so it looks like both of these for 180 becomes -A, -B, but they don't swap. Okay, let's check and see if that works. So for B, I had a +2, which became a -2, and a -5 became a +5. So that works. Okay, so let's look at 270. So 270, we have 5, 2. And this one's 3, 5. Okay, let's look at our originals. So, so B prime was 2, -5, so we swapped, but then the y became negative. So let's try that one out. So -BA A versus B negative A. So now it's negative BA. Okay, and let's check it with this one. So that means they swap, and then this one will become positive. So it's, since it's negative, negative is a positive 3, 5. So that works. Now 360, it's just going to be AB because it rotates all the way around back onto itself. And then 90 degrees counterclockwise is the same thing as 270. So this is the same. Okay, so I was just messing with you. So 270 is around here. So this is 270 degrees clockwise, or 90 degrees counterclockwise. Okay. All right, let's look at combining transformations. So if we have T1, T1 is a reflection about the x-axis. T2 is a rotation clockwise about the origin. T1 and T2 denote the rotation and then the reflection. So we do the rotation first for T2, and then we do the reflection. So we read from right to left when we're doing our transformations. Okay, so if I have T2, T1, it denotes a reflection first because T1 is a reflection, and then the rotation is done. So we perform transformations from right to left, and order matters. That's very important. Order matters. Okay, so first let's take a look at what's going on here. So I have my original figure A, B, C, D. Okay, so then I see, okay, this one is a single prime here, but these are double primes. Okay, so I am moving first here and then here. So how is that happening? Okay, so let's take a look at our coordinate points. So the first coordinate point is -3, -1 right here. And this one is at -2.5. And then we have -2. C ends up at, let's see, that's -1 and -2, and B prime, or the original B, is at -1, -1. Okay, so let's look at where did they end up. Okay, so A is at 1, 3. So it's swapped and opposite. So if this is AB, this one is -B, -A. That's interesting. Let's see if that holds up. Okay, so this one is 2.5. And again, it's swapped, and it's the negative version of this. So if they're both negative here, that would make the negative version both positive. So we're seeing something interesting going on here. So C prime, this is at 2, 1. Okay, so I think we've seen that this is this translation here. When we look at a transformation sheet, here we don't see that. Okay, that's, it's not, we see X, Y, which is 180-degree rotation. If we reflected on the x-axis, and then the y-axis, we wouldn't get there either. So let's use tracing paper. You can use wax paper or parchment paper for this. So let's figure out what just happened here. Okay, so somehow we got to here to there. Okay, So we're looking, that's definitely a reflection around the x-axis, but that's the second transformation. So we're trying to get over here. So if we're rotating, if we pin down the origin right here and we rotate, that's not a rotation. Okay, so the rotation would end up like that. Okay, so we don't have a 180-degree rotation here. Okay, so what we do have is we can start joining the corresponding points. Okay, and we can see, oh, hey, we can get a line of reflection that's not quite what we're used to, but if we join these points, we can see, oh, this is a reflection, but it's about a really unusual axis. Okay, so the center of reflection's right at the origin, and it just cuts through like this. So we have a reflection, and this is called y equals negative x. So our first translation is a reflection about y equals negative x. All right, so then this next one here, if we're moving here to here, we can take a look at what we've got with the coordinates. So this one's negative 2.5, and it's at 1. Okay, so A prime. Okay, so let's see, 2.51. Okay, so I would say, oh, I'm sorry, that's 3. That's why I'm like, what? Okay, so that's negative 3, 1. Okay, so that's changing this up. So we're alternating and the y is negative. So if we look at this, we alternate and the y is negative. So if it's xy and then the becomes yx, that's a 270-degree clockwise rotation or 90 degrees counterclockwise. So we can see that with our, we can see if we had this right here and we rotate clockwise, it would rotate right onto itself. So the second rotation is 90 degrees counterclockwise or 270 degrees clockwise to get to double prime. And use tracing paper when you're doing these things. It helps a lot. Okay, so the last part of this is we're going to reflect M, or M is a reflection about the y-axis. R is a rotation, A negative 180 degrees. So that'll be negative A, negative B. So we want to perform R. So R is the rotation. So all we're going to do is change everything to the negative. So if we have okay, so if this is 1, 2, then we're going to do negative 1, negative 2 for B prime. Okay, if this is 4, 1, then we count 1, 2, 3, 4, and negative 1 for C prime. And if this is 3, 4, it's negative 3, and then negative 4. So I need one more here. 1, 2, 3, 4, and 1, 2, 3. So 1, 2, 3, 1, 2, 3, 4. So that's going to be A prime. Okay, so then I can connect that up together. Okay, so that's my 180-degree rotation. Okay, so then perform MR. So we did the rotation first because we do from right to left. So then we have a reflection about the y-axis. So this is the y-axis here. So our reflection is just going to be here for B double prime. And then A is 1, 2, 3, 4, 5, 6. So we count, 1, 2, 3. So 1, 2, 3. So we have A double prime. And then C is 1, 2, 3, 4, 1, 2, 3, 4. So we have C double prime here. So this gives us our reflection around our y. Our y-axis from here to here. All right, so what if we had done the reflection about the y-axis first and then the rotation? Would we be in the same place? Okay, so let's take a look. So if we're reflecting about the y-axis, so that puts us over here. So let's make a bigger, I'll reuse this and save a tree. And we're going to call that B, C, and then A is up over here. So we reflect around the y-axis over to this point here. And then C is going to be right there. Okay, then we do a rotation of 180 degrees. So that gives us 1, 2. So we're counting 1, 2, 1. So that means 1, 2, 1. So that puts us in the same spot. Okay. And then this one would be 1, 2, 3, 4, up 1. So 1. Okay. So let's just see if we can do this. So we have a radius of rotation right here, which is 1, 1, 2. So 1, 1, 2. So if we rotate this, it actually ends up more like that. So it's not quite in the same spot. Okay, so let's try that again. So we had that there, we rotated across 1, 2, 1. So this is our angle of rotation. This is B, and then C is going to be rotating. Okay, so it's not quite in the same spot. Okay, so it should, well, maybe it is. Okay, so it shouldn't be in the same spot, but if it, because you shouldn't be able to do the translations in reverse, but sometimes it does end up in the same spot, which is a very unusual situation. So this again is going to be one of those that's an unusual situation. So we reflect around the y-axis and then rotate around here, and we have the same figure. Okay, so it's a good idea to use this when you're not quite sure of what you're seeing. Okay, so anyway, so you just have to remember right to left. In most cases, it will not be the same. Okay, order matters. Have a wonderful day. Bye-bye.